A bodkin arrow fired from a 150-pound warbow strikes a breastplate at 30 meters. The arrow hits with over 100 joules of energy, enough force to penetrate an inch of wood. The arrow crumples against the steel plate and falls to the ground. The armored knight doesn't even stumble. This isn't Hollywood. This is physics. And everything movies taught you about arrows piercing armor is about to collapse. Today, we're testing what actually happens when the best arrows meet the best armor. The results will change how you see every medieval battle scene, what plate armor actually is. Plate armor from the 15th century wasn't costume decoration. It was engineered protection built by craftsmen who understood metallurgy and geometry. A complete harness of Milan or Gothic plate armor consisted of articulated steel plates covering the entire body. Breastplate, backplate, pauldrons for shoulders, vambraces for arms, gauntlets, cuisses for thighs, greaves for lower legs, sabatons for feet. The steel was typically 1 to 2 millimeters thick for most plates. High-quality armor used medium carbon steel hardened to around 30 to 40 Rockwell. This created plates that could flex slightly under impact without denting permanently or cracking. But here's what makes plate armor devastating against arrows: the curved surfaces. Every plate is shaped to deflect impacts away from the body. A breastplate isn't flat, it's rounded, angled, designed so that strikes glance off rather than hitting perpendicular. This geometry multiplies the armor's effectiveness. An arrow that might penetrate 2 millimeters of flat steel has to penetrate 4 or 5 millimeters of effective thickness when hitting a curved surface at an angle. And most arrows hit at angles because the curves ensure it. Plate armor evolved specifically to counter the threats of the late medieval battlefield: longbows, crossbows, early firearms, lances, swords, axes, polearms. It had to stop all of them. And for about 150 years, from roughly 1400 to 1550, it largely succeeded. The longbow test. The English longbow was the most feared projectile weapon of the 14th and 15th centuries. Draw weights of 100 to 180 pounds. Arrow velocities around 45 to 55 meters per second. At close range, a heavy warbow could deliver over 100 joules of kinetic energy. Against mail armor or leather, longbow arrows were devastating. Bodkin points, narrow armor-piercing arrowheads, could punch through mail rings and penetrate several inches into the body. This is why longbows dominated battles like Crécy and Agincourt. But those battles were fought in 1346 and 1415. Full plate armor wasn't common yet. Most soldiers wore mail hauberks with some plate reinforcement. Knights had partial plate. The longbow faced primarily mail and padding. Modern testing using historically accurate reproductions shows what happens against full plate. A bodkin arrow from a 150-pound longbow, fired at 10 meters, point-blank range, fails to penetrate a properly made breastplate. The arrow either crumples, shatters, or bounces off. At 30 meters, a more realistic combat distance, penetration is impossible against quality plate. The arrow simply doesn't have enough energy, even if it hits perfectly perpendicular, which almost never happens due to the armor's curves. It can't punch through 1.5 millimeters of hardened steel. The longbow didn't become less powerful. Armor just evolved past its capability, where arrows can kill. But knights in full plate armor did die from arrows. Historical accounts are clear about this. So, what's happening? Gaps. Every suit of armor has them. Armpits, where the arm needs to articulate. The inside of the elbow, the back of the knee, the groin, the visor slit in the helmet. These gaps are covered by mail or leather, not plate, because plate in those locations would prevent movement. An arrow that hits these gaps can penetrate. Mail provides some protection, but a heavy arrow at close range can force rings apart or break them. This is how arrows killed armored men. Not by punching through breastplates, but by finding the vulnerable points. The problem is hitting those gaps. A knight in combat is moving. The gaps are small. The arrow is in flight for a fraction of a second. At 50 meters, you're not aiming for the armpit. You're aiming for center mass and hoping. This is why massed archery was effective even against armored opponents. If 5,000 archers loose arrows at a formation of 500 knights, the probability that some arrows find gaps increases. It's not precision, it's saturation. But individual arrows against individual armored knights, the knight wins almost every time. The crossbow difference. Crossbows hit harder than longbows. Heavy military crossbows with steel prods could achieve draw weights of 300 to 1,200 pounds using spanning mechanisms. The bolts were shorter and heavier than arrows, concentrating more energy on a smaller point. Against plate armor, crossbows performed better than longbows, but still couldn't reliably penetrate quality breastplates. Testing shows that even 1,000-pound crossbows struggle to punch through properly hardened 2mm plate at combat distances. Crossbows did have an advantage in finding gaps. The flatter trajectory meant more predictable aim. The shorter, stiffer bolt was less likely to deflect off curved surfaces. But ultimately, crossbows faced the same problem. The gaps were vulnerable. The plate was not. What crossbows could do was dent armor. A powerful crossbow bolt hitting a breastplate might not penetrate, but it could dent the plate inward. If that dent was severe enough, it could bruise or injure the wearer through the padding underneath. This blunt force trauma could incapacitate without penetration, but this required very powerful crossbows at close range, and it wasn't as reliably lethal as a penetrating hit. If you're realizing every movie armor scene is wrong, subscribe right now. Why armor declined? If arrows couldn't defeat plate armor, why did armor eventually disappear from battlefields? The answer isn't about arrows. It's about three different pressures that converged in the 16th and 17th centuries. First, firearms. Early arquebuses and muskets couldn't reliably penetrate quality plate armor either. But firearms evolved faster than armor could adapt. By the mid-1500s, heavy muskets could penetrate all but the thickest armor at reasonable ranges. Making armor thick enough to stop musket balls meant making it so heavy that soldiers couldn't move effectively. Some armor smiths created bulletproof breastplates, 4 to 5 millimeters thick. These worked but weighed so much that only cavalry could use them, and even then mobility suffered. Second, cost. A complete harness of quality plate armor cost as much as a small farm. Equipping large armies with full plate was economically impossible. As armies grew larger in the 16th century, from thousands to tens of thousands of soldiers, the economics of armor broke down. Third, tactics. Pike and shot formations dominated 16th century battlefields. Massive pike blocks with integrated firearm units. These formations emphasized unit cohesion over individual protection. A soldier in formation didn't need full armor because the formation itself provided protection. Armor declined, not because it stopped working, but because the entire tactical and economic system that supported it changed. Arrows had nothing to do with it. What testing actually shows. Modern experimental archaeology has tested this extensively. Organizations like the Royal Armories and independent researchers have fired thousands of arrows and crossbow bolts at reproduction armor using historically accurate weapons. The consistent finding is that quality plate armor from the 15th century is essentially immune to arrows at combat distances. Penetrations only occur at point-blank range, under 10 meters against thinner plates, typically 1 millimeter or less. And even then, penetration is inconsistent. The tests that show arrows penetrating armor use either unrealistically thin plates, mild steel instead of hardened steel, or completely flat plates instead of curved armor surfaces. Change any of those variables to match historical armor and penetration becomes extremely rare or impossible. This matches historical sources. Accounts of battles from the 15th century, when full plate was common, describe arrows bouncing off armor. Chronicles mention knights bristling with arrows stuck in their armor, but still fighting. The Burgundian chronicler Jean de Wavrin described arrows rattling off French knights at Agincourt like hail on rooftops. The sources and the testing agree. Arrows didn't penetrate plate. They found gaps, caused blunt trauma, and killed horses. But the idea of arrows punching through breastplates is Hollywood fiction. The uncomfortable reality. Medieval warfare wasn't about individual duels where skill determined survival. It was about probabilities, economics, and attrition. A knight in full plate armor was nearly invulnerable to arrows striking his protected areas, but he wasn't invulnerable to 1,000 arrows fired simultaneously. Probability alone meant some would find gaps. He wasn't invulnerable to being knocked off his horse by an arrow that killed his mount, or to being swarmed by infantry with poleaxes once he was dismounted, or to exhaustion, heat, and the simple fact that fighting in 50 pounds of steel is physically brutal. Armor made you much harder to kill. It didn't make you immortal. The men who died in armor died because warfare creates situations where even the best protection fails. They died from falls, from blunt trauma, from gaps in their armor, from sheer numbers overwhelming them. But they didn't die because arrows pierced their breastplates. The physics doesn't allow it. The testing proves it. And understanding that changes everything about how medieval combat actually worked. Armor wasn't invincible, but it worked far better than any movie has ever shown. And that's a truth written in steel that no Hollywood arrow can penetrate.